All right, we want to use the linear approximation of a given function at x equals 0 and approximate a specific value of that function. So the equation for linear approximation, we have f of x is approximately f at a plus f prime at a times x minus a. Now a is where we're going to center our approximation. It's where the point of the tangent line. We're using a tangent line to make our approximation, to approximate our function. So at what point do we have a tangent? It's at this point x equals 0. So that's our a. So what we're really looking for is f of 0 plus f prime of 0 times x minus 0. So that means we need to figure out f of 0 and f prime of 0. We need to take our function and evaluate it. F at 0, looking at our function, is e to the 0 over 0 plus 1. So e to the 0 over 0 plus 1, that's just 1 over 1. So that's 1. That's fine. We're going to need f prime of x so that we can get f prime of 0. So for f prime of x, we're going to have to use the quotient rule. We're going to have 2e to the 2x times x squared plus 1. That's the derivative of the numerator times the denominator, minus the numerator times the derivative of the denominator over the denominator squared. And there's the quotient rule. We know it always gives us something ugly, but that's okay. In this case, all we care about is f prime at 0. So we just need to evaluate that at 0. We have 2e to the 0, 0 plus 1 minus e to the 0 times 0 over 0 plus 1 squared. So that is 2 times 1 minus 0 over 1, so that's a 2. So great, all right. So our function, f of x, is approximately f at 0, which is 1, plus f prime at 0, which is 2, times x minus 0, so just x, right? Going back to this that we had here. So that's it. That's our linear approximation. That's a good, reasonable answer because that is actually the equation of a line. If you get something here that's not the equation of a line, you've done something wrong. It is a linear approximation. So that's our linear approximation. That's a nice, easy function to deal with, and that's the advantage here. Our original function is ugly and messy, and we don't want to deal with it. But near 0, our original function can be approximated with this guy, which is a pretty friendly little function. Not bad at all. So that's our linear approximation. F at point 1 is approximately 1 plus 2 times 0.1, which is 1.2. And that is our approximation to our function at 0.1. We got it from the line above, the linear approximation above. So we get a good approximation without having to evaluate our ugly function. That's it.